I mean, 'cause, like,
Pretty much. Now, here's the difference is that molar ratio you were talking about earlier, those are counting numbers because they came from a balanced equation, and a coefficient is an actual whole number for a whole amount. So that's infinitely significant. We wouldn't consider those moles from a balanced equation to be a measured number. We would consider them to be a counting number.
So if you had 3 moles of some element equals this many molecules, you would not consider the 3 a measured number?
Not in the way that you stated it there. That's correct. But don't sweat it too much right now because we'll get plenty of practice with this, and you'll be good at this before you even realize it. Okay?
If the answer has like less numbers than the
That's a very good question. What if the answer has fewer numbers than the least precise measurement or calculated number in the problem? Got to add zeros. Yep.
Could you explain when a 0 is significant and when it's insignificant?
I will be happy to. That's one of the things I hope to get to today. Did I see another hand up? Yep.
things that don't have zeros.
I see what you're saying. You don't add zeros when you're adding numbers together. You're right. But your final answer, but we're talking about the final answer now, not to a measurement you're putting in where you're just putting zeros to line them up.
But what if the problem was just like in the actual problem itself, there were a lot of numbers, but then your calculator couldn't show all of them. That's the reason it's too small. You couldn't add zeros to that one.
I don't think we're ever going to have that happen in here. But if it ever happened, then you would have to show the zeros to show the right number of digits. Okay? So, but I don't think we're ever going to have any calculations where you have so many digits in all the measurements that your calculator won't handle all the digits in the answer. I don't think that'll happen. Okay? I've never seen it happen before. Okay? Those are good questions, though. Great. Anything else before I move on? All right, does that help you? Okay, good. All right, so we've covered how to figure out how to line up numbers to figure out your significant digits when you're adding and subtracting. We've repeated here how to line up or figure out what your significant digits are in your multiplication and division, right? So maybe the next thing to do would be to go to significant zeros. Let me just look real quick. Wasn't really where I planned to go, but I can do that now. All right, let's talk about significant zeros then. I just got to remember I got to jump back a little bit because I do want to get to something else that actually comes. Well, maybe not. We got it. Then I guess this is the best place to go now. Yep.
Can we put these on the note, continue from the notes we did yesterday?
Absolutely.
What page is significant zeros on?
I think it's the first page of the new section that I gave you yesterday, page 24.
And it starts on the last page.
Yeah, it starts actually on the last page of the previous section I gave you. Like we're down by the third at the bottom or something. Significant zeros. Okay, significant zeros can get a little tricky sometimes, only because you got to remember the category we're talking about. Okay, so let's start first with the category of when you're given a number. Or you measure a number, okay? And you've got a measured number or calculated answer you've already been given, okay? So if I have something like 2.00, okay, and that's maybe milliliters of methanol, okay? All right. These zeros will be significant, and here's why. This meets what I like to call anyway, the two-part rule. Okay? The two-part rule states that zeros are significant when they follow both a decimal place and a non-zero digit. When I use the word follow, I mean to the right of. Does that make sense? Follow meaning to the right, because that's the way we read. Okay, anybody here read Hebrew? Okay, Hebrew goes to the left. Every language I know of goes to the right. Although there may be some Oriental languages that go vertically. I don't know. Who knows? Okay. All right. So we typically, in the United States anyway, read to the right. So when I say follow, I mean to the right. Okay? Now, so any zeros, to the right of both a decimal place and a non-zero digit will be significant. All right? Okay. The other category are zeros that are between two significant digits. That's the one-part rule. So we've got a two-part rule where you have both decimal place and non-zero digit, two parts. And this is between two significant digits. I call it a one-part rule. All right? So if I have 0.2 milliliters of methanol, okay, this zero is significant because it's between two significant digits. I guess I should have said in the beginning, non-zero digits are always significant in this context. Okay, anytime you have a measurement that's already given to you, or you do a measurement, or you have a calculated answer given to you already, or some value given to you, in that context, then zeros that are between two significant digits are always significant, and non-zero digits are always significant. Yes.
The first one, how come the second zero is significant if it doesn't follow non-zero?
Well, it does. It's just, it's just over this way. I can put.
So it doesn't have to be like exactly next to it.
How far you want me to go? Oh, shoot. I'm sorry. Okay. So all those zeros are significant because they follow a decimal place and a non-zero digit. Okay? Not right next to it. That's correct.
So if it was 0.00, those zeros to the right of the decimal place, those would then be?
All right. Those zeros, the way you stated it, were to the left. Let's look at that. 0.00200. Okay? Let's make that liters of methane. Okay? Methanol, I'm sorry. All right. Now, these two zeros are significant because they follow this non-zero digit and they follow this decimal place. However, these zeros are not significant. They are not following both the decimal place or non-zero digit, and they also are not between two significant digits. And the shorthand for understanding this is these are leading zeros, and leading zeros are never significant. I don't want to give you a third rule. That's just an additional rule that sometimes helps. Does that make sense? You really don't have to memorize that rule, that the leading zeros are never significant, but sometimes it's just a fast way of stating the reason why they're not significant. Okay? Yep.
So that number you would have to put it in times 10%.
No. This is perfectly okay. Well, but you're a chemist now and you should know that. They're not significant. No. That's a perfectly good number to leave it like that. Let me show you where you have to use scientific notation. Okay? Let's jump a little bit ahead here to the category where we calculated an answer. Well, let me see if I might be able to come up with one, just sort of develop one here. Let's say I have 207.4 milliliters of methanol, and I'm going to add that to 142.6 milliliters. Wait a minute, that's not. No, I can't. That's not going to work. I'm sorry. Huh? No, adding's not going to work. What I was trying to illustrate. I don't know why I was thinking to do that. Let's say I've done a calculation like one of these conversion calculations, okay? And I end up with an answer that has 260.0 milliliters of methanol. But I need my answer in two significant digits. In that case, I'm going to have to round off a digit that's in the ones place, okay? And this is the one time where it's required. Now, you can write it in scientific notation. That's perfectly okay. That's not what you asked me. You asked me, do you have to? We don't have to write this one in scientific notation. But if you wrote in scientific notation, it'd be perfectly okay.
You said, if it's insignificant, you're not supposed to have it on there.
No, you round off any insignificant digits. But these are place keepers. Okay? They're place keeper insignificant digits. So it's a different category. You can keep the place keepers. Okay? But technically, it's like they don't even exist. If you wrote it in scientific notation, they wouldn't be there. Isn't that right? That's what you're thinking about, correct? Okay. But it's sometimes it's a lot simpler. Is it simpler to write this or write it in scientific notation? Which requires less writing? I don't know. This would be faster to me. Let's see, 2.00 times 10 to the negative 3 liters methanol. Not a whole lot of difference, I guess. Okay. So, but if this is easier for you, it's a perfectly okay answer. Okay. But now, if I have to round off a number in the ones place, now I've got to write it in scientific notation. And here's why. Let's move my decimal place 2 places to the left, and so the answer is going to be 2.6.
Why are you rounding off on the ones place? Why are you rounding off?
Just as an example.
Oh, as an example.
Yeah. 2.6 times 10 squared milliliters methanol. Okay? All right. Suppose I tried to round this off without getting rid of, let's do this. How about we say we have 261.4 milliliters is the answer we get from the calculator after some conversion. I need to round off these two digits. Okay? If I try to write this as 260, well, that's not right, because that's zero. That's really just leaving an uncertain digit that nobody knows what that is. Okay? Or if I try to write it as 26, well, that's an order of magnitude smaller. We can't say 26, can we? Are those anywhere near an estimate? No. Rounding, it doesn't make sense. So in this case, we have to say 2.6 times 10 squared milliliters of methanol. Okay? Does that make?
Anytime you have to round to ones place, you should
Huh?
number it.
Anytime you've got to round a number from the ones place, you've got to write it in scientific notation. But that's the only requirement.